Today we're going to do 3-5, solving exponential and logarithmic equations. And our objective will be able to solve exponential equations. First, for any exponential function, f of x is equal to b to the x power. If we have b to the u power is equal to b to the v power, then u equals v. So here, what is that saying? The same base raised to exponents equal to each other. The exponents are equal to each other. For any logarithmic function, f of x is equal to log base b of x. If we have log base b of u is equal to log base b of v, then u equals v once again. So we need to write those down. The reason log base b of a number needs to be equal to this number as well. So let's use two examples with this. First, 64 to the negative 2x power is equal to 16 to the negative 3x power. We first want to look at 64 and 16 and think about, well, how can we make a common base? I know that 16 is the same thing as 4 squared. So if I have 4 squared to the negative 3x power, I now have a power to a power, and I multiply these two powers to make this 4 to the negative 6x power. I then look at the other side and think about 64. 64 is the same thing as 4 to the third power. So 4 to the third power to the negative 2x power would give me 4 to the 3 times negative 2x would be negative 6x. Now, since I have the same base of 4, I can set my exponents equal to each other, giving me negative 6x is equal to negative 6x. If I solve for x, I get 0 equals 0, which means I would have all real solutions as my answer. I can also use this with our logs. If I have log base 17 of 1 minus 5x is equal to log base 17 of 5x minus 9, well, I can use that property we just talked about and set those equal to each other, since I have log base 17 equals log base 17. So 1 minus 5x is equal to 5x minus 9. I solve for x by adding 5x to both sides. 1 is equal to 10x minus 9. Add 9. 10 is equal to 10x. Divide by 10. And x is equal to 1. I then take my 1 and plug it in to make sure that it works. So log base 17 of 1 minus 5 times 1 is equal to log base 17 of 5 times 1 minus 9. 1 minus 5 means log base 17 of negative 4, which is equal to 5 minus 9 log base 17 of negative 4. Although this is equal, it's log base 17 of negative 4 is equal to log base 17 of negative 4, we're taking the log of a negative number, therefore we have no solution. So when we're solving log equations, we need to make sure that our answer does not give us a negative log. And then we have exponential equations where we can't rewrite. So the first thing we are going to do is 1, get what is being raised to the power alone. So what is being raised to the power? 20 to the negative 7x power. In order to get that by itself, we need to get rid of the 7. So we subtract 7. And I get 20 to the negative 7x is equal to 32 minus 7, which is 25. And now I can't rewrite the bases of 20 and 25, so I have to use the inverse. And we have talked about the inverse of exponential functions being logarithmic functions. So I am going to log both sides of my equation. And I will be left with the log of 20 to the negative 7x power is equal to the log of 25. And we know that with a log, and we have an exponent, our exponent can come to the front. So if we can come to the front, then we have negative 7x times log of 20 is equal to log of 25. So once we got what was being raised to the power alone, we log both sides. And in order to know that we have to log both sides, we check for a common base. If no common base, we log both sides. And then we solve for x. So we used our power property to bring that exponent to the front. And now in order to get x by itself, since it's being multiplied by negative 7 and log of 20, I am going to divide by negative 7 log of 20. We are left with x is equal to, and in your calculator, we are going to do the log we want base 10 of 25 divided by, and we need to put this in parentheses, so open parentheses, divided by negative 7 times the log of 20. Close your parentheses, enter. And we get an answer of negative 0.153. And our last problem is a log equation. For our log equation, we first need to have one log. So we need to condense. Here we have two logs. log base 7 of x minus log base 7 of x plus 2 equals 2. So since I'm subtracting these two logs, I can divide the x and the x plus 2 to condense it to log base 7 of x divided by x plus 2 is equal to 2. Once I have one log, I rewrite in exponential form. So I do the circle. Seven to the second power is equal to x over x plus 2. 7 squared is 49 is equal to x over x plus 2. I need to multiply by my denominator to cancel it, so x times x plus 2 times x plus 2. 49 times x is 49x. 49 times 2 is 80 plus 18, which is 98. Is equal to x. Subtract 49x. 98 is equal to negative 48x. Divided by negative 48. And x is equal to 98 divided by negative 48 is negative 49 over 24. I check. When I plug in, I have a negative log and a negative. Therefore, we have no solution.